Hello, students. Welcome to Inside Physics. I am Srinivas. Today, we will continue straight line motion. In the previous lesson, we have discussed some definitions and introduction. What is a straight line? What is a straight line motion? What is speed, distance, displacement? Okay. Today, we will discuss what is velocity, acceleration, and relative velocity. Okay, see here, velocity. What is velocity? We have discussed speed in previous lesson. Speed is equal to distance by time, distance covered in unit time. Here this velocity is displacement covered in unit time. So we can write velocity is equal to displacement. Now what is displacement? By time. The shortest possible distance between the initial and final points of a moving object is called displacement. So here if the displacement is more, that means velocity is more. If, for example, to know in a better way, if an object is moving from A to B, A to B in a straight line motion. So the shortest distance, that means the displacement is, suppose it is 20 meters, and this distance of 20 meters is covered in a time span of, suppose, 5 seconds. So what is the velocity here? Velocity is displacement 20 by time 5 seconds, that is 4 meters per second. So unit of velocity is meters per second. So here what is the difference between speed and velocity? Speed we have learned in the previous lesson. Okay. Speed means it is the distance traveled, the total distance traveled. That means the path length by time. See here, if an object is moving in a circular path, it has started at A and traveled in a circular path. The radius of circle is R and ended at the same point. Now here the distance covered is 2 pi r, perimeter of the circle, and the displacement is 0. Right? Why displacement is 0 means here the initial and final point is same. What is displacement? The shortest distance between initial and final point. If the initial and final point are same, then the displacement is 0. Distance is 2 pi r, displacement is 0. If the displacement is 0, in this case, what is the velocity? Displacement 0 by time of travel, that is 0 by anything is 0. So in this case velocity is equal to 0. So here in this way we can take an example to calculate the velocity. Next, what is uniform velocity? Okay, what is uniform velocity? If an object is traveling from one point to another point, so if it is covering an equal distances, right, if it is covering an equal distances in equal intervals of time, so that is called uniform velocity, and the object is moving, we say the object is moving with uniform velocity. Here listen, equal distances in equal intervals of time. Suppose the object is moved from A to B, B to C, C to D it is traveling a to b, b to c, c to d. Okay, in a traveling in a path. Here A to B is suppose 10 meters, B to C suppose 10 meters, C to D suppose it is 10 meters. Equal distances covered in equal intervals of time. Suppose for 10 meters it took 5 seconds, and this 10 meters it traveled in 5 seconds. This 10 meters it traveled in 5 seconds. So here it is, the object is covering equal distances in equal intervals of time. So here we can say the object is moving with uniform velocity. If an object is moving with uniform velocity, the equation of motion can be written as at plus b. Okay. Here a and b are some variable constants. This x is the position of the displacement of the object. So here, if the initial position of an object is having some displacement, if the at time t is equal to 0, if this object is having some displacement, so the position and time graph of this equation of motion can be written as, can be shown here. This length is b. Okay, and here the time is t naught. The equation of motion will be like this. T naught means at time t is equal to 0, the object is having some initial distance and it is traveling in this path. So with time is increasing, the displacement is also increasing. Okay. So if time is equal to 0, at time is equal to t naught, the displacement of the object we can write x naught is equal to b. This is the representation of equation of motion when a body is moving with uniform velocity. Okay, next. What is a non-uniform velocity? Non-uniform velocity. See, when an object is covering in unequal distance displacement, unequal distances in equal intervals of time. The first condition, we are explaining non-uniform velocity. If an object is moving with covering unequal distances in equal intervals of time, or it is covering equal distances in unequal intervals of time. I will tell you with one example. This is non-uniform velocity. Non-uniform velocity. See, equal distances in unequal intervals of time. The same example we have taken here. Object is moving from A, B, C, D. A to B, B to C, C to D. Okay. So equal distances. Suppose this is again 10 meters, 10 meters and 10 meters. Equal distances in unequal intervals of time. Unequal means this distance suppose is covered in 3 seconds. This is covered again in 6 seconds. And this distance it is covered suppose in 2 seconds. So then in this kind of motion, you can, if you observe this, the velocity is changing. 10 meters to cover first 10 meters it took 3 seconds. Next 10 meters it took 6 seconds. And the third 10 meters the object traveled for 2 seconds. So equal distances is covered in unequal intervals of time. So then the object is said to be moving in with non-uniform velocity. And in the reverse also, the unequal distances in equal intervals of time. See, unequal distances means suppose this is 20 meters, this is 10 meters, this is 30 meters. Unequal distances, suppose this is 5 seconds, covered in 5 seconds, this is also 5 seconds, this is also 5 seconds. Unequal distances covered in equal intervals of time. Here also 20 meters it took 5 seconds, and here for 10 meters it is taken 5 seconds, it is 30 meters in 5 seconds. So here the velocity is 4 meters per second, here the velocity is 2 meters per second, here the velocity is 6 meters per second. So velocity is changing when the object is in motion, varying. Varying means non-uniform. That is why we can say the object is moving with non-uniform velocity. Why the displacement or the displacement is changing means, see, the it may be because of the magnitude of change or in direction. So the displacement of magnitude or direction of displacement is changing, then the velocity will obviously will change. See, suppose if an object is moving in a curved path, then obviously the displacement will change. When it is moving in a straight line, the displacement is different. So if the object is changing its direction, then the displacement will obviously change. Then the velocity, what is velocity? Displacement by time. Displacement by time. So obviously velocity will also change. Okay. So next, what is average velocity? Average velocity. See, average velocity. See, the average velocity can be written as total displacement by total time. Total displacement covered by total time. So to understand this in a better way, we'll take one example. If an object is moving is in a distance of, right, x1 to x2, this is horizontal coordinates, this is an x-axis and y-axis. Suppose an object has moved from x1 to x2. At t1, object is at x1, at time t2 the object is at x2. So in this case, what is the average velocity? I told you total displacement by total time. If this is not actually displacement here, this is the position coordinate. If an object is moving in a rectangular coordinate system and x1, x2 are the position coordinates at t1 and t2. In a time being, if the time has changed from t1 to t2, the object has moved from coordinate x1 to x2. In this case, we can write the average velocity as t2 minus t1, x2 minus x1 by t2. See, the difference of position coordinates gives the change in displacement by change in time. Okay, this gives the average velocity. So here, and this can be written as change in displacement means delta s by delta t. Delta represents the change in time, a small change in displacement. Okay, this is when the object is given in a way of position coordinates. Suppose When an object is covering a distances displacement of s1, s2, s3 up to sn distance displacements covered in a time of t1, t2, t3, tn. See, this is S1, S2, S3, S1, Sn displacements covered in the time limits of T1, T2, T3, Tn. So, in this case, what is the average velocity? Here actually the displacements are straight away given and the time covered for these displacements are also given. What is the average velocity? Total displacement by total time. Here total displacement is S1 plus S2 plus S3 up to Sn by total time T1 plus T2 plus T3 up to Tn. This is the average velocity when the object is covering with n displacements in n time limits. Okay, this is average velocity, concept of average velocity. And next we move to instantaneous velocity. What is that? Instantaneous velocity. What is instantaneous velocity? The velocity of a body at a particular time of incident, at a particular time, that is called instant. Instantaneous means what is instant? At a particular position, at a particular time. So the velocity of a body at a particular time of travel is called instantaneous velocity. So what is the actual definition of instantaneous velocity? Okay, so this can be also can be considered as the limiting value of average velocity. Limiting value. So see, here I will write in this form: delta t, limit of delta t tends to 0, delta s by delta t. So when there is a change in displacement with respect to change in time, however small may be the time almost tends to 0. That means if an instantaneous velocity is to be calculated, we can go up to the infinitesimally small time also. The time interval may be however small it may be. So delta t almost tends to 0 but not 0. Here this is equal to ds by dt, change in displacement by change in time. This is called instantaneous velocity. Okay. So here what it actually gives is at a particular time, however small may be the time interval. You can take in sometimes in microseconds also. Okay. So however small may be the time interval. So that is about instantaneous velocity, and we can see one note here from this. See, velocity is equal to ds by dt. So that implies v dt is equal to ds. So if you can take the integration part, that means s1 to s2, t1 to t2, this is v dt. The variable here is displacement, here the variable is time. So this is, we can represent this in an integral form in this way. And another note, so the average speed is always greater than average velocity, right? So if the average distance is also greater than average displacement. So if first the distance covered is always more than the displacement, so thereby we can say the average speed is always greater than average displacement. Average speed is always greater than or equal to average displacement. Why? Because average distance covered is always greater than or equal to average, sorry, here average velocity. Okay. So here if, and note, in second note, we can see that if an object is moving from A to B with a velocity VA, okay, and B to A with a velocity VB, okay. So here A to B, B to A, the displacement is 0. Okay, the displacement is 0 means here the velocity is also 0. So here VA minus VB, that means VB minus VA, VB minus VA is equal to 0. So in this way we can understand the concept of velocity. First we have taken velocity, uniform velocity, non-uniform velocity, average velocity and instantaneous velocity. Okay. So next we will move to the concept of acceleration. Okay. What is acceleration? Acceleration is nothing but rate of change of velocity. Rate of change of velocity. What is rate of change of velocity? The velocity, the change of velocity per unit time. Okay. What is acceleration? Acceleration is a good concept. We will use this acceleration term and the definition of accelerate and the concept in so many topics of physics and the particle accelerators in higher science. So the acceleration term you should understand very carefully. Here it is represented with A, and acceleration is rate of change of velocity. Okay. So the change in velocity, that is equal to dv by dt. Change in velocity per unit time. I will tell you with some example. Suppose an object is moving from A to B and then B to C and then C to D. Okay. So it is moving A to B, B to C and C to D. A to B it is moving with velocity of 5 meters per second, and here 10 meters per second, here 15 meters. The velocity is increasing. Okay. So from here to here the time it is taken is, suppose it is 2 seconds, 2 seconds, 2 seconds. So the velocity is increasing with the time. So here the change in velocity, what is the change in velocity? 5 meters per second. 5 meters per second. Okay. It is increasing 5 meters per second for every 2 seconds. In this case, how can we, what is the acceleration? So 5 by 2, 2.5 meters per second square. See, acceleration, units of acceleration is meters per second square. Okay, so this is the concept of acceleration. See, when a body is moving with acceleration, acceleration means the velocity, it is starting with zero. The velocity is continuously increasing. Suppose when we are going in a car, we start the engine, we will move, and we will start starting the car, we are getting accelerated from 0 speed to 20 kilometers per hour, 30, 40, around 70 to 80, around 100 kilometers. Then in this case, we can say the car is accelerating, the velocity is changing, that means increasing with time. So in a span of 2 to 3 minutes, the car has reached a speed of 80 kilometers per hour. So here, that is the acceleration, the positive change of velocity, the increasing trend of velocity. Here acceleration means the increasing trend of velocity with respect to time. Okay. So here also we need to see some terms of average acceleration. See, average acceleration, something similar to velocity. The change in acceleration, average acceleration, is equal to the change in velocity with respect to time. So if an object is having a velocity at a time at a v1 at a time t1, and it has moved some distance having a velocity v2 at a time of t2, in this case the average acceleration is this one with meters per second square. Okay, so again, with this we can calculate the instantaneous acceleration also. What is instantaneous acceleration? Again, limit delta t tends to 0, delta v by delta t, that is equal to dv by dt. Rate of dv by dt is rate of change of velocity, that is called instantaneous acceleration. The limiting value of average velocity. See, instantaneous acceleration is the limiting value of average acceleration. Okay. See, in instantaneous acceleration, this time limit will go up to whatever smaller we can get, up to infinitesimally smaller time also. Okay. So average acceleration, this is instantaneous acceleration. See, acceleration is nothing but the change of positive trend of change of velocity, the increasing trend of velocity with time. Okay. So here in acceleration, the main thing is the velocity change. Unless there is a velocity change, we cannot say that is moving with, the object is moving with acceleration. If there is no change in velocity, that means here it is moving with 10 meters per second, here also it is moving with 10 meters per second, then there is no change in velocity, that means we can say the acceleration is 0. It is moving with constant velocity. Constant velocity means acceleration is 0. When there is a positive change of velocity only, then we will say the object is moving with acceleration. Okay. Then uniform acceleration. The next definition. Uniform acceleration means when it is moving with the changes of velocity, the equal changes of velocity in equal intervals of time. When an object is moving with equal changes in velocity, this means change is the important word. Change in velocity, not velocity. Here change in velocity. Equal changes in velocity with equal intervals of time. Equal intervals of time. Then we mean to say that the body is moving with uniform acceleration. So thereby we can also say non-uniform acceleration also. So unequal changes in velocity with equal intervals of time, or equal changes in velocity with unequal intervals of, just like our uniform velocity or non-uniform velocity. Okay. So if this concept is about velocity and acceleration, and these formulas and the concept of whatever we have discussed up to now: speed, average speed, velocity, average velocity, distance, displacement, acceleration, these are all used to calculate the values in a motion, in a one dimensional straight line motion of an object. We will calculate some values when we deal with the problems. So here, next we will see, after this, what is a relative motion. What is a relative motion or relative velocity also? What is relative velocity? See, this average speed and average velocity, average speed and average velocity has some more importance in this lesson. See, we will understand this only, this average concept, average, suppose average velocity or speed. This has some importance, and we will have some problems at intermediate level and at NEET or IIT mains and advanced level also. We will need to we have to understand the average velocity or speed concept in a better way. Just we will deal with one example to understand what is exactly. So I'm going back again to average velocity to explain you with one example to understand in a better way. So if you take the time value on x-axis and the, suppose we take displacement on y-axis. Okay. So here we will calibrate the x-axis, suppose in 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 seconds, suppose. Here the displacement is 5 meters, 10 meters, 15 meters, 20 meters, 25. We can write some another term 30 also, 30 meters. So it is in meters, it is in seconds. So here I will show you one graph. By that we will calculate the average velocity. Okay, here this is 15. Okay, this is exactly a straight line. And here see, between 15 and 20, I will take this as, suppose, 18. And here the object has, drawing a straight line needs some skill. Okay, here 28. Suppose between 25 and 30, the point I have taken is 28, this is 18. And this time limit is 15, 25. Okay. So here what is the average velocity? We need to get the average velocity from this graph. So we know velocity average velocity is equal to v2, sorry, s2 minus by t2 minus t1 meters per second. Here the position of the object at 15 seconds is 18. Okay, so if we consider this as s1, this as this point 28 is s2, this time limit is t1, this 25 is t2. Okay, here the position coordinate s2 and minus s1. So this formula we have already seen how to take this formula, average velocity s2. What is s2 here? This one, 28 minus 18, right? t2, 25 minus t1, 15, that is equal to 10 by 10. So 1 meter per second is the average velocity. This is how we will calculate average speed or velocity. If in on y-axis, instead of displacement, if you take distance, then you will get here average speed. In place of velocity, we will get average speed. See, this diagram tells us how the movement of an object with time in the journey, we can get the average velocity. Okay, so with this example, I think you might have understood in a better way. So next we will move to relative velocity. What is a relative velocity? Relative velocity is a good concept. So the term relative itself tells us that there is a comparison, right? The term relative itself tells us there is a comparison. We are comparing one velocity with another velocity, one motion with another motion. So relative velocity, suppose I am moving in a car in a highway with 80 kilometers per hour speed. So besides me, another car with some higher velocity is moving with 120 kilometers per hour. So compared to my car and the car besides me, which is moving with higher speed, so the relative velocity will be in between these two cars is the higher velocity minus the lower velocity. That is, the relative velocity is 120 minus 80, that is 40 kilometers per hour is the relative velocity, not actual velocity. See, my car is moving at 80 kilometers per hour. So the car besides me going with much more higher speed, 120 kilometers per hour. So actual speed 80, for this car actual speed is 120, but the relative speed. So if I am in this car and I am observing this car appears to me actually moving with 40 kilometers per hour, but actual speed is 120 kilometers per hour. But if any other person standing on the road, suppose beside on the side of the road a person is standing, he is at rest. So if this person observes this car is moving with 80 kilometers per hour, he can feel that it is moving, and it is also moving with 120 kilometers per hour with respect to the man standing here. And but the relative velocity, the people sitting in both the cars will observe one another with the difference of velocities between these two cars. That is called the concept of relativity. There is a comparison. That is called relative velocity. So okay, so with another we will take another example to understand it in a better way. So if there is in a railway platform, okay, there are two tracks, there are two railway tracks here. This is track 1, this is track 2. Two trains are moving in this direction, and a person on the platform is standing here. This is railway track 1, railway track 2, and a passenger is standing on the platform. A train is moving with velocity Va. Suppose Va. This train is moving with velocity Vb, or you can say speed. So if the passenger in this train feels that this here Vb is greater than Va, suppose Vb is greater than Va, this train is moving faster. So here if a passenger is observing from this train, he will say this train is moving faster, and it will cross this train with a velocity Vb minus Va. Okay, so if a passenger in this train will say that same thing, this train is crossing this train with a velocity, this with this difference of velocity. Okay, but a passenger here standing here on the platform, see, he says this train is moving with velocity Va, and he can see this train is moving with velocity Vb, and he will see this train is crossing this train is crossing this first train with a velocity of more than this train. That is also, see, you cannot feel the difference of velocities of this train, but he can say that this train is moving faster and crossing this train with some velocity, but the difference of velocities are felt by the passengers inside the train. So because they are moving relative to each other and he is standing, he will feel the actual velocities of the train. Okay, but in the passengers in the inside the train, they feel the difference of velocities of these two trains. That is called relative thing. Compared to what? I am at rest, I am at rest compared to what? Compared to the objects also at rest. So this is the concept of relative velocity. Okay, so here if you want to take the positions of two objects, okay, moving from x a to x b, if you take two objects moving with, if you take one object moving from xa to xb with a velocity va to vb, va to vb, here the relative velocity, the equation of relative velocity can be written as xa is equal to x naught of t, okay, t naught plus va t, and xb is equal to x naught of t naught plus vb t. See here the velocity, the change relative velocity can we get from this solving by these two equations. Okay, this is the position coordinate of object at point B moving from A to B and with velocity V to VA to VB. it will, the velocity will be changing from va to vb in a time limit of t, and the position is also changing from a to b in a time of t. So at the relative velocity after some time of an object is also considered with these equations. So in this way we can see the concept, we can learn the concept of motion with these kind of definitions and examples, and we will move to the equations of motion. The equations of motion we will derive, and we will discuss the equations, very important regarding the learning the equation of motion in a straight lines. Okay, in the next lesson we will discuss those equations of motion in detail. Okay, thank you.